Hello team, we're going through this beautiful data structure called segmented tree. I will go through the example, but you can do some research about it, how it works, as a context, but I'm going through like the implementation and the details here. So imagine we have it like this, one small array here, and this small array has like 1, 2, 3, 4, which is technically is 5 because we are starting from 0, and then we have this number here. So in the first scene, for my example, we're going to this situation. Imagine if I want to know the query that I need to know all the like summation of the numbers that I have here. So what is that? So I have 5, 4, 3, 2, and 1, which is 15, right? It's 5 or 9, 12, 14, and 1 is 15. So that is so simple. Or imagine if I want to have a query that I want to see the number from index 2 to an index 3. What's the sum of this? It's 3 and 4, which is 7. Or if I want to go see the sum of 2 to 3 2, 3 is 5. It's pretty simple. Why we need to have a like segmented tree. It's really a small array, but if you have something with the size of 10, 5, then it's pretty one. So it's a pretty big one, and then what you can do is really hard to make the frequent query. If you want to make the query from here to 1 to 2, probably it's easy, but if you're going on the way down and you want to have a query, imagine if you want to have a query here from 2 to 4, but you already have the query from 3 to 4, and you already have a query 2 to 3. So what you can do, you just can use the already calculated queries. So if you have the big, I'm saying big is like really pretty big arrays, and you want to have a query over then these arrays multiple times, so you don't need to recalculate this query all the time. You just have do all the calculation stored somewhere somehow, and then you can reuse them. That's why the segment tree comes into the game and can help you. So let's explain to you how it works. So clean up here. Okay, the first step is that we need to build a tree. This build a segment tree. I put some tree ideas here, and then you can see how it works. So firstly, we need to have a like the parent node tree. The parent node tree is start from index 0. So what we have here, we need to have something called index. Then what we can do something else. We're going through the situation that, because segmented tree is like the full binary tree. If you don't know it, doesn't need it, you can just look at it later, but we don't need it. I'm just saying that all the keywords, you can just look it up later. So what we can do here, from here we have an index, right? So the index 1 in index 0 is the parent. So from here we need to build a tree. To building this tree, which is like have a left child and has a right child, left and right child. So firstly, we need to understand what's the index of this one. So what I can put the name here, I say left, I put node, or you can put a child, say right node, which is here. So to calculate the left and right, you need to have some like formula here. It's really simple formula. The formula is here is for the left child, we have this one. We have a 2 times index plus 1, which is this one, and you have a 2 times index plus 2. So this is the left one. Let's I change the tagging. So this is left node, and this is right node, and for right node this is right node, and this is the left node. So let's go through this formula for now. So we know the index of these should be based on this formula. What is that? We are starting from 0 here, and then for this tree, which is want to like show the segmented tree, and we represent in this array here, what we do for index 0, 2 times 0 plus 1 is 1, so this is 1, and then 2 times 0 plus 2 What is that? This was 0, 0. That's 2. So I have a left and right. So the second step is that we want to know how can we go through that one, because this is like 0. We want to go through the range of that. So node here, this is like parent node. What represents index 0 is from 0 to 4. So that's the range. They call it range. For example, like from 0 to 4. It's really small array, for example, but could be like really big and big. And then from here, we need to calculate the node, which is here is node 1. What is node 1 is representing here? What the range that node 1 representing? To calculate this one, we need to this formula. We need to number that shows the what's the range. So the building the tree is based on this one. For building the tree, we need to have a couple of the things. For the first thing that we need to know build, I call it build, where we need to start, where we need to end, and what's the index. So you can see where we need to start, what's the range, where we need to end, and what's the index. You can map it here is pretty easily. So let's go from this way. For a start and end, for index, I have a 1 based on this formula, which is based on that. For a start and end, we can build this one based on this situation. For the left node, what we can do here, let's I put this one here. For the left node, I have this formula, say left, I can call it left build. To building the left side of this tree, like this way, we do this. We have a start, then we have a mid, then we have a index. Don't worry about the mid, we come into it like a little bit like that down. For right, building the right part, which is this part. I said right build. What we can do this. Let's I make this one cleaner. So we can do this way. We can start from start, because will be mid plus 1. I will tell you why. Then will be end, and then will be index. So this is the way that we're going to make this tree. So let's just clean up here a little bit and then move this one here. Then you can see exactly what's going on. Perfect. The first step is that we need to create the left one. Okay. For the left one, what we can do, this is like the you really understand how the recursive works here, like recursive function. If you have any issue with the recursive calls function, really you understand here. So because I will create another video for the code, but right now let's go through the concept, because you can get from concept to code, but it's really, I'm not saying hard, could be complicated from the code to get the concept. So from here, let's go to the situation of left. So for the left build, we have a start, mid, and index. How can we calculate mid? For calculating mid, let's get this color. Mid is pretty easy. So for calculating mid, what you need to know, you need to have start plus end minus start. Let me clean this one. Start divide 2, and this is mid. Yes, some people do this way too. Start plus end and then divided by 2. The reason is that it works because I'm just going through quickly, but you can look at by yourself later. If you have a too big number here, then imagine you have a too big integer. int dot max plus int dot max, then what will happen? You have an overflow. So to manage this one, this is the technique that is end minus start. But probably in your question, LeetCode, anywhere else, you don't need to all the time this one, but it's like really good defensive system. And it's pretty clean. So I just get rid of this one. That was extra here. So we have a meet. To use meet, what we can do here, see, we have a meet here. So technically, for the first iteration, you will see why we need meet. The index is 1 because we calculated here, right? It's 0 plus 1, then is 1. So for making the left child or left node, we need to have a start, meet, and index. So what's the range of here? The range here is, what is the start and end here? Start is 0 and 4, right? We have the formula here. The formula is here. Our start is 0 and is 4. If I put this one in this formula, that will be the situation. It will be like start is the start. I put the start here. Then mid will be here. Will be like start is 0, 2 minus 0, and then this plus, and then will be what is will be like exactly will be 2. Sorry, end is 4 here and the start is 2. Will be like start here, sorry, start 0, and then will be 2, right? Okay, so here make it better, 4 and the start is 0. Start, I put start, I put end here. You can understand what's going on. So this is for range of this one, 0 to 2. For the range of the right build, which is the right child, is easy because here what you can do, start will be mid plus 1. What's the mid here? It is 2. Maybe this one. And what is, let's say, killing this one, make it better. This will be 3. And here will be like 3. And then what's the end? End is 4. So there is no magic here. Just based on this, we can build the tree and goes down and see how it works. So right now I'm going one more, but the question is that how much I need to go down, how much I need to just expand this tree. But if you bear with me, you will see why we're going this way. So the next one will be here. This is technically a binary tree here. I have a 2 node. If I go through the same formula, what is that? Right now index is 1. For the left, if I put the 1 here, will be 2 plus 1 will be index 3. And then from the right child, what's the index? Index is 4. Right, so we're going down. For index, what is the range that we have? If I put this one, the formula, the same formula here that we all need to calculate the range. Left build is range is based on this formula. What's the start here? The start will be 0. The mid based on this formula, if you put that numbers here, will be like start plus end start this. So I won't go through all of that. Let's make this one a little bit here. Then you can see more. Then this one for this one too. So perfect. So what you can do here, we need to for mid. So for mid will be 0 based on this one will be 1, right? Why? Because we have a 2. If I put 2 here, you select this, mid will be 1, right? So right now let's calculate, go down here and see how much is we need to go down. So we have a node, the index is 3. We're going down and you will see there is a, based on this one, the index of this guy on the left will be 7 because 2 plus 3 is, sorry, 2 times 3 is 6 plus 1 based on this, right? This is a 7. What's the range that this guy is covering? If I put this range based on the left one, say start, mid, and index, you will see start is 0. And then what is the mid? The mid is, if I put this the number here, you will see the mid will be 0 too. So see how it works. 0 plus 1, 0 divided 2. What is that? 1 divided 2 is 0. So we get in 0 here too. So we're going more down. But there isn't like the point here. The point is that if you see, we should stop here. Why? Because we cannot go more than that. And then you will see in the code, but this the law is here. If you see start is equal to end. You can see 0 is equal to 0. So that's like the point that we need to stop it. In like programming, they call it just like the use case. Sorry, there is a base case that you can get out of that. Get out of the like your dynamic programming. We have like some recursion here, and then we can use that one. This could be branch of the dynamic programming, but sorry, I said dynamic programming is like out of the recursion. So, and you will see in the code more. So the place that the stop of it is here, right? Okay, let's try the other node here. The other node that I need to know is this one. See, the blue one, right build. The right build, the index of the right node is this one. So 2 times 3 is 6, plus 2 is 8. And then range of this one is so easy. You have it like here. Maybe, see, mid plus 1. Mid was 0, so 1. And then maybe end. What's the end here? The end here is 1. I highly recommend to you just not formalize this one, but this is the how that like we build a tree, but you don't need to formalize or memorize the things. You just maybe draw once, you will watch the video a couple of, maybe 2-3 times, really understand how it works. And we have a golden rule here to get out of this expanding tree forever. We say start and end if is equal when we stop. Start and is equal if we stop, right? So whenever that we are hitting that golden rule, I could call it, like start plus is equal to end, what we can do, we can do a couple of the things. The first thing is that we can fill up this node. Why? 0, 0 represent the node 0 here, right? The node, well, this element 0 in an array. So what we can do, we just put here 1. Let's see this get color. Can do 1 here. 1 to 1, yes, I have this rule. What I can do with that, 1 to 1 is present element 1. So what we can do, that was element 1 was here, see, is 2. Is 2. So I will put 2 here, right? 2. So let's expand the tree here for this node 4. The node 4 is here. If I just calculate this one, I have an index. This is the index 4, right? This is index 4. So I need to find the left child and the right child for this one. Let's see what's the range that this guy is covering. He's a right build. Right build is a mid plus 1 and end and the index. Sorry, put the index here. Let's make this one cleaner. Index here. Then perfect. So what we can do here, so we have a mid and then we have it. So the mid here is 1, right? So here the range is covering mid plus 1 will be 2. Technically mid plus 1 is a start for this guy. And what's the end for that? The end is 2. It's 2. Oh, that's the rule. We got the golden rule. So what we can do, we can just do the same things. What is the 2 and 2? 2 and 2 is here representing 3, right? So I put 3 here. So let's go through this one. We just done here. We go back. We cannot do anything. We go back here. We cannot do anything. And then we come back here. So we need to see if we can expand from here. So let's make this one a little bit better. Just get this one out. so it's better this way. Yes. So okay, from here what we can do, we exactly same things. We're going through the left child and we're going to right child or not. So for the left child, what's the index here? Index is 2. If I put this in this formula, for it is for the left child, 2 times 2 plus 1, 2 times 2 plus 2. So 2 times 2 plus 1 is 4, it will be 5, and this guy will be, yeah, 2 times plus 2, and then it will be 6, right? So what's the range that we are covering here? The range that we are covering here will be, start for the left, build, we have this formula, right? We have this formula. So what we can do, we will be like start is 3, and for mid, if I calculate the mid from this one, is if I put this one in the mid calculation, you will see 3 here plus 4 minus 3 is 1, and then divide by 2, you will get this number, which is 3, right? So here, oh, interesting, we got the golden rule, right? So the golden rule is that if start is equal to end, which is start equal to end, go here. What is the 3 representation here? The 3, number 3 is here, and then what we can do here for number 3, we put 4, right? Same deal here. So if I just going to see what's the range that I'm covering here, the range that I'm covering here is, okay, let's see, the right node. For the right node, we are using this one, mid plus 1 end. So what's the mid here? The mid here was this one, right? 4. What's the end for this one? The end is here, right? It's 4. Don't formalize the things here, but this is how the way the it's built. But if you just really carefully look at this one, it's not really anything magical. I'm saying here, when you're covering from here to here, it's a range, right? When I'm covering here to here, for the right node, you need to cover a start from here to end. So a start from here means, because I already covered this one, with plus 1 means like, okay, I already covered here. If you can see here, start, and then here I have mid, and I have an end here. That's a plus 1 coming. I already calculated here. So what I need to start, I need to start mid plus 1, right? Because already mid is already calculated. I don't need mid. So mid plus 1, I need to start from here to here. That's how it works, right? Because this is, I want to cover everything. I want to cover everything that I have here. So that's how it works. So it's not magical. Nothing is magical here. Everything is just pre-math, I can call it. If you hate math, doesn't matter. This is not really math. So this is the how we building tree. And then last step that I forgot put here is this guy, 4 and 4. See what's here? 4 and 4 is 5, right? Right now you have a tree. What you can do with this tree depends. Imagine if I want to, based on the example, I say I want to have a sum of the elements here. What's the sum of the 1 and 2? Sum of the 1 and 2 you can see is, let's like pick another color, is 3. Oops, not this color. Let's get this color. Is 3, right? This is 3. So what is the sum of the 3 and 3? Is 6, right? What is the sum of the 5 and 4? Is 9. And what's the sum of the 9 and 6? Is 15. Sorry, this is really small. I can make it bigger like that. This is 15. And then this is the 6. What was this one? This one was 9. Okay, now it's fitted there. See it? 6, make it bigger. Okay. So how it works, see, I have a tree, that this tree here, what it can do, you can see, get the calculation of that. So we just going all the way down to get this rule, means that we get into the single element, like this represent the single element in the array. and then the parent of this is covering this range. That's like the strength of segmented tree is coming. So you can see how can I, if I can make the query from, oh, what's the range of 0 to 1, I don't need to calculate this one again, already I store it here. But in the next video I will show you the code and just match the code next to this tree that we drawn, and then you can see how strong this one. But right now we have, see, if you look at here, we have the sum of 1 plus 2, right? But you can have a, what's the max of this one? 2. What's the minimum of this one? 1. You can just build a tree based on the rule that you have, anything that you want to put. You can use a GCD common divisor, but great common divisor, but you don't need to do complicated like that. But only things that you need, right now, put the sum is really easy. You don't need to do min and max, but you can change this tree, building tree based on the policy. But the tree structure is building this way. That's called segmented tree, and the segmented tree is segmented. Is technically, the segmented tree is telling you the range that you want to query, the range that you want to query, the range that you want to, the range that you want to query. That's how it works here. Thank you. I will upload another video about the how we make the code, but don't look at the code. I had the same issue before. Just understand the concept. Code can come automatically and doesn't matter any program language. See you in the next video.